This video involves how do we add rational expressions. So remember, you already have an understanding of what rational expressions are. Those are expressions that contain a variable denominator, all right? So we've got two scenarios that we need to explore today. One is, how do you add these rational expressions together when they have common denominators? And how do you add these rational expressions together when you have uncommon denominators, or the denominators are not the same? All right? So adding with a common denominator. The first step, if you need some steps here, here's a guide for you, is we want to identify that we have common denominators. All right? Once I identify that we have common denominators, I want to call them the LCD and then factor that LCD if possible or if I need to. So for example, right here, I notice that I have a denominator of 8y squared and 8y squared. Those are exactly the same, so we're going to identify them as our LCD. And our LCD here would be 8y squared. Now, because this is a monomial, there's really no need to go ahead and factor it, all right? So I go to step 2. It says determine the restriction on the LCD. Well, I know from what we've previously done, the restriction is y cannot equal 0. All right? It's really not going to have that big of an impact while we're doing things like adding and subtracting. But as soon as we move on to solving, it's going to have a major impact, these restrictions. All right? Step 3, go up to the numerators now and combine the like terms. So I have 1x plus 1x. All right? And that would give me 2x. Or I'm going to go ahead and write down 2x. And then I have y plus negative y. Well, I know those are going to cancel out. All right? I take that, and now I'm going to bring that denominator that we had back in. I combine my numerators, and now I bring that denominator back in, 8y squared. I then look at the remaining piece, this new term, and say, can I simplify it? Well, I notice that both the top and the bottom are factorable by 2, or in other words, 2 over 8 can simplify. So I would rewrite this as 1x over 4y squared, and then bring in the restriction and say, don't forget, y cannot equal 0. This is it. All right, pretty simple when you have a common denominator. But let's look at this one where the denominator gets a little bit more complex. Well, anytime I see something that looks like I can factor it, I go ahead and try to factor it. I also notice that both these denominators are the same. So however the first one factors, the second one's going to factor the same way. All right, I know that this first one will factor to v minus 4 and v plus 2, which means the other one is going to factor the exact same way. And I have a common denominator here in factored form of v. So v minus 4 times v plus 2. I know that that also tells me I have a restriction here that v cannot equal 4 or negative 2. I now change my focus to the numerator. Because I had common denominators, I'm simply going to combine my numerators. V plus v is 2v. Negative 5 plus negative 3 would be negative 8. I look at that numerator, and in this numerator, recognize, hey, wait a minute. I can simplify that by factoring. I notice that there is a GCF of 2, so I'm going to rewrite this as 2 times v minus 4. That is as simplified and as factored as I can make my numerator. I'm now ready to take the numerator and the denominator, the LCD, and put them together. So I have 2 times v minus 4 divided by v minus 4 and v plus 2. All right? From this position, I recognize, wait a minute, the top and the bottom have common binomials. So therefore, I can cancel these v minus 4s, which would leave me with the result of 2 over v plus 2. Now remember, you can't cancel those 2's because In the numerator, the 2 is a monomial, and in the denominator, the 2 is part of a binomial, all right? But I still have the same restrictions I did back from the LCD, that v cannot equal 4 or negative 2. Okay, so what if the denominators are not the same? What if we have uncommon denominators? First, we want to factor all denominators and determine what is the LCD. What is the common denominator between any and all of the fractions that we have? Once I determine that, figure out the restriction. Then we're going to do something that I refer to as playing the game. And the game is, what am I given in the first numerator? What am I missing from the denominator and how it compares to the LCD? This is a little bit tricky, but hopefully I'll explain it clear enough. We repeat that playing the game for any fraction that I have. We're then going to combine our numerators, simplify those numerators, and factor the numerators. Then we're going to bring the denominator in and look to see if we can simplify or cancel any more. And then we're going to finally have our end result and write the restrictions. All right? So let's start off kind of easy here. I've got a bunch of monomials. The first thing I want to do is identify what is my LCD. So I'm specifically looking at 4x squared y and 5. I know that from the numbers, the LCD would be 4 times 5, or 20. We have x squared, so we have to have x squared as part of the LCD, and y, which we also have to have as part of the LCD. This tells me that I have restrictions that x cannot equal 0 and y cannot equal 0. All right? Now I'm going to do what I call play the game. The game exists by using the numerators and the denominators. Here we go. I know that I am given in the first fraction 5 as a numerator. Write down 5. This is what I call given. I now compare the first denominator to the LCD. In the first numerator, I do not have the LCD. What value am I missing from the first numerator to make the LCD? I am missing a 5. All right? The 5 times 4 would give me 20. So I write down what I'm missing. Then I write plus what I'm given, 6y. And I look at the second denominator, 5, and say, what am I missing that would create the LCD 20x squared y? Well, in that one I am missing 4x squared and y. Like I said, this part right here might take a little bit of extra practice and thought, but as soon as you get it, you're going to find out, wow, this is pretty easy. I'm going to simplify 25 plus 24x squared y squared. I'm going to combine like terms, which I can't, but I also know that I could rewrite this in a different order if I wanted to. This is simplified. There's no GCF, and it can't be factored. I take that numerator, 25 plus 24x squared y squared, and I bring in the LCD, 20x squared y. I look to see if anything can cancel. There is no common factor in the numerator, so there's nothing that's going to be able to cancel it with the 20 in the denominator, or for that matter, the x's or the y's. Remember, the numerator is a binomial. It's got to be in both parts for it to be able to cancel with the denominator. This is my final answer, which also contains the restriction that x cannot equal 0 and y cannot equal 0. All right, let's take a look at this next one. So in this one, I recognize that my LCD would include this m plus 5. So I'm going to write down LCD is the binomial m plus 5. And I look at the second one and notice, oh yeah, I've got this one, but I also need this one as well. So the m minus 5 would also become part of the LCD. From this, I know that I have these two restrictions, that m cannot equal -5 or +5. And yes, it's okay if you write plus or minus 5 there. I have found the LCD and its restrictions. Step 2, play the game with the numerators. Here we go. I'm given 3m. I look at the denominator m plus 5, and I compare m plus 5 to our LCD. I am missing the m minus 5 in the LCD. Plus, I'm given 4. I look at the denominator. I notice I have m minus 5. I'm missing m plus 5. So it's what's given, what's missing, what's given, what's missing. All right, now I'm going to go ahead and multiply this out. I have 3m squared minus 15m plus 4m plus 20. I'm going to combine my like terms. I have 3m squared minus 11m plus 20. All right, so now I'm in a kind of a pickle right here, and I say, all right, can I factor this? Well, to check it, I'm going to go to goal number factoring. And I'm going to say, all right, I have a goal number of 60 and a middle term of -11. If I start trying factors, first of all, I need two numbers that are both negative. Why? Because they have to multiply to give me a positive, and they had to give me -11. So I'm thinking like, what if we start with -3 and -20? Nope, that's not -11. How about -5 and -12? Nope. How about -6 and -10? Nope. I think I'm out now. I mean, there's other ones that I could check, but there's no way I'm going to get -11, which tells me this was not factorable. All right, I take that new numerator, 3m squared minus 11m plus 20. I bring in the LCD, m plus 5, m minus 5. I don't need to multiply them together. And this would be my simplified singular fraction. This also gives, don't forget I have a restriction that m cannot be plus or minus 5. All right, a couple more problems here. I have an LCD here. Well, let's see, I see a 3 there, but I see a polynomial I need to factor. So this is going to factor to m, what do you think? Minus 6, m minus 5. So we have an LCD of 3 times m minus 6 times m minus 5. Restrictions, m cannot equal 6 and 5. Okay, there's my LCD. All right, I look at my numerators. Start with what's given, 2. Look at its denominator, 3. I am missing m minus 6 and m minus 5. Okay, so I've got a little bit of work ahead of me there. Plus, I'm given 3m. Look at its denominator. Compare that to the LCD. I'm only missing 3. So I'm going to write a 3 in there. All right. So to speed this up a little bit, I'm going to rewrite this first one as 2m minus 12. That's 2 times m minus 6. And then I'm going to FOIL 2m minus 12 times m minus 5. That would be 2m squared minus 10m minus 12m plus 60. Now I'm over here, plus 9m. All right, I'm going to combine my like terms. I have 2m squared. So let's see, this would be minus 13m plus 60. Ooh, might be factorable, so I'm going to check it, 120. And I need to add to give me negative 13. So it's got to be a double negative. I'm going to start with negative 10 and negative 12. All right, that's not going to work. All right, if I keep going, I'm not going to notice anything, I don't think. All right, let me just play around with a couple other numbers. So if I do negative 5 and negative 24, they're getting further from negative 13 than negative 10 and negative 12 were. So I'm pretty confident that this can't be factored. All right. I bring in that numerator, 2m squared minus 13m plus 60, and compare that to my LCD of 3 times m minus 6 times m minus 5. There's my simplified singular fraction. The restriction, m cannot equal 6 and 5. All right, the last one I've got for you here, take a look at this. First thing that I notice on this is I got a GCF in the 2x plus 2. So I'm going to rewrite this as 2 times x plus 1. All right, I got to find my LCD. LCD, I've got 2 and 2x, so I know that that's going to be a monomial of 2x and the binomial of x plus 1. That sets up the restriction that x cannot equal 0 or negative 1. All right. I go to my first fraction. Numerator is 6. Look at the denominator. What's missing? X. Go to the second numerator. Now it's a binomial. I could factor it. I don't need to. I've got 5x minus 5. Look at its denominator. Compare it to the LCD. I'm missing x plus 1. So when I simplify here, I've got 6x plus 5x squared plus 5x minus 5x minus 5. And then when I combine like terms here, I've got 5x squared plus 6x minus 5. Can that be factored? I don't know. I've got a goal number of negative 25, a middle term of 6. I need a positive and a negative number that I multiply to get negative 25 and add to give me 6. All right, I've got 5 and negative 5. I've got, let's see, negative 1 and 25. Is there anything else? Not that I can think of. All right, sometimes you're going to be able to factor that, guys. Sometimes you're not. We just haven't been able to yet. So I've got 5x squared plus 6x minus 5 divided by the LCD of 2x times x plus 1. Don't forget my restrictions. X cannot equal 0 or negative 1. Hope this helps. Good luck. Let me know if you have any questions.